So, have you ever really thought about what happens when you click a link? I mean, in that tiny little split second, something you do on your screen travels across the world and back again. Today, we're going to follow one single piece of data, a packet, on that incredible journey. We are going to pull back the curtain on the magic of the internet, one hop at a time.
It feels like magic, right? You click, and a web page from a server that could be thousands of miles away just appears. But behind that incredibly simple action is a ridiculously fast and complex delivery system. And to really get how it works, we kind of have to change how we think about the internet itself.
You know, the best way to think about it is to imagine the internet as a giant global postal service. Seriously, sending a little packet of data is a lot like mailing a letter. To get a real letter to the right person, you need two things, right? You need their street address, but you also need their name. Well, the internet works in pretty much the exact same way, using two different kinds of addresses to solve two different problems. And this right here perfectly illustrates that idea. First, you've got the global address. That's like the street address, the city, the zip code. It's what gets your packet to the right network, anywhere on the planet. But once it's there, you need the local address. That's like the person's name on the envelope. It's for finding the one specific device, the one computer or server inside that entire network. The absolute genius of the internet is how it juggles these two different jobs. Okay, so let's start at the very beginning of the journey. Before our data packet can go racing across the globe, it has to do something much simpler. It has to get out of your house. This is what we call the first mile. It's the short trip from your laptop over your Wi-Fi to your router. It all happens right there on your local network. So for this purely local trip, devices use something called a MAC address. The easiest way to think of this is like a permanent serial number that's burned into the hardware of your device. It's a unique fingerprint that never, ever changes. So when your laptop wants to send something to your router, it addresses it specifically to the router's MAC address. It's the digital version of handing a letter to a specific person inside a building. Now, this slide is absolutely key because people get these two things confused all the time. First, you have a switch. A switch is just the local mail sorter. It only works inside your local network, using those MAC addresses to shuffle data between your laptop, your printer, your TV. But a router, well, a router is the interstate highway director. Its job isn't to connect your devices to each other. Its job is to connect your entire network to other networks. It's the on-ramp from your quiet little street onto the global internet.
So our packet has made it to the router. It's hit the on-ramp for the internet's superhighway. Now, the router does something really important. It basically strips off all that local delivery info, the MAC address stuff, and gives the packet a whole new set of directions for its long-haul trip. From here on out, we're dealing with that global address we talked about, the IP address.
This right here is the whole secret to how the internet works. Your home router has no idea where that server in, say, Japan actually is, and it doesn't need to. It just needs to know the very next step. It looks at the packet's final destination IP address and just says, to go there, you need to head to this next router. It's just like asking for directions and only being told the first major highway you need to get on. And this is really the essence of it all. The packet travels in a series of these hops. It gets handed off from one router to the next, and each router along the way makes one simple decision. What's the next best step from here? This whole system of simple handoffs is what makes the internet so incredibly powerful and able to grow, because no single device has to know the entire map of the whole internet. Okay, so after hopping across who knows how many routers, maybe thousands of miles, our little packet has finally arrived. It's at the destination network, the digital neighborhood where the server lives. And now, everything we saw at the beginning just happens in reverse. It's time for that final local delivery, the last mile. So this is the final critical handshake. The last router in the chain, it knows the server's global IP address, but remember, for that final delivery, it needs the local MAC address. So it basically just shouts out to the whole local network, hey, who here has this IP address? The target server hears that call, and it's the only one that responds, saying, that's me, here's my MAC address. Boom. The router now has the exact local address it needs, and the packet is delivered. So let's just step back for a second and appreciate how elegant this whole design is. This little dance between the local MAC addresses and the global IP addresses is what makes the entire modern internet possible. It's a two-tiered system that brilliantly separates two problems. The big problem of finding the right network in the world, and the small problem of finding the right machine inside that network. And this design is what gives the internet its superpowers.
It's scalable. You can add millions of new computers tomorrow, and the system doesn't even blink. It's flexible. You can have Wi-Fi at home, fiber optic cables under the ocean. They all speak the same global language of IP. And maybe most important, it's robust. If one of those routers on the path goes down, traffic just instantly gets rerouted another way. It is a true network of networks, and it's built to survive.
But here's the really mind-bending part. The core ideas we just talked about, they were designed back in the 1970s for ARPANET, a tiny network with just a few hundred computers. And today, that same basic architecture connects billions of us. But as we move into the future, with the Internet of Things promising trillions of connected devices, from our cars to our toasters, the big question is, can this 50-year-old design really handle that kind of future? And that is the grand challenge for the next chapter of the Internet.